this is a quick explanation of my code. So we've got my solve function here. Outside of the solve function, I've created this. It's a thread-safe dictionary, which I wanted to exist outside this function because this is useful for every other test case that occurs. I guess I'm keeping a record of all the values pre-computed earlier so we can save time, save runtime later on. So the first thing this function does is it takes in this number, this long, and checks if the thread-safe dictionary, or I guess it's called CD because it's a concurrent dictionary, if the dictionary already has this value in there. If it does, it returns the value. So the key is this this long value, and the value of the pair is the solution, how many hyperbinary representations exist for that number. So if it contains it, it returns it. Otherwise, it goes to base case 1. So base case 1 is basically for all numbers that are exactly 2 to the k. Then the amount of representations are k plus 1. So this line checks if log 2 of that number that's input in is an integer. And because it's a float, it's a long, this is kind of a hacky way of doing it. I did have double epsilon in here, but it would break for case 17 when sum was such a large number, when the log of 2 was also a large number, would break. So this is basically just making sure that this is very, 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 very close to 0. And if that is the case, then k is that this log 2 sum, and try to add it to the dictionary if it's not already in there, and then return k plus 1. Similarly with base case 2, where it's just checking here if log of sum plus 1 is an integer, then the answer is 1 for all numbers. That's true. So again, we check it that using this little comparison, we try to add it, and then we return 1. And then we have our recursive call for even numbers. So if this is an even number, then we compute this new n, and these are the 2 lines which we're adding the pairs to the dictionary to save on runtime later. So we try and add this n plus 1 and the recursive call for n plus 1, whatever the answer ends up being. And we also try and add n and the recursive call for n. And then we also need to return these solutions. And then we have the recursive call for odd numbers, which is very similar. We compute this new n, and then we try and add n and the call of n, and then we return the solution of n. So I have this that I had a playthrough when I was trying to work out one of the cases that wasn't working. So I think this is test 9. So when 6370 is called, so it's if we look at the code again here, so because it's an even number, the even number has these 2 calls, n plus 1 and n. So here this is n and this is n plus 1. So then this is, again, it gets called, and this is even. So again, there's a n plus 1 and an n. And then for each one again, so this one's odd, so the odd just calls this, it just calls this. But every time there's an even number, it calls twice. So you can kind of see how it grows. And in terms of storing numbers in the thread-safe dictionary, so 198 is going to be storing 2 plus 2 plus 2 plus 2 plus 1 plus 2 plus 2 plus 2 plus 1 plus 2 plus 2 plus 2 plus 1. All right. Whereas, say, just 5 stores 2 and 6 stores 3. You can kind of see how it works its way up. So this these four all have the same number here. And 6,370 is this entire bottom row all added together.